right, ladies and gentlemen, here we go. I think probably the easiest and best way to think about this is to think about a coordinate plane and really thinking about ordered pairs. In quadrant 1, what are the signs on an ordered pair? Positive, positive. And in quadrant 2, what are the signs? Negative, positive. And in quadrant 3, we have the signs negative, negative. And in quadrant 4, we have positive, negative. Okay. You're with me now, right? Okay, good. So the nice thing is when we're thinking about like the unit circle in these quadrants, then it was really nice because the first, the x-coordinate gave us the cosine of the angle ratio and the y-coordinate gave us the sine ratio. And that pretty much holds true. So when we're looking in which quadrant is the sine ratio positive, well, sine is positive in quadrant 1 and 2. Yeah, 1 and 2. So quadrants 1 and 2. All right. Then we have in which quadrants is the cosine ratio positive? 1 and 4. Very good. So right here, cosine is positive, and in quadrant 4, cosine is positive. So 1 and 4. I'm just going to write regular numbers now. All right. And last but certainly not least, where is the tangent ratio positive? 1 and 3. Very good. How do you know that? Because tangent is sine of theta over cosine of theta. So we can simply divide. Positive divided by positive gives us a positive result. And down here in quadrant 3, negative divided by negative gives us a positive result for tangent. And so that's really, really good. Do you like thinking about it like this? Not really. Not really. Can you think about the quadrants?
Yes.
Yeah? All right.
We should go to 5.0. We should go to 5.0.
5.0. What?
Instead of 4.4.
You don't want to skip to chapter 5. We got a long time before we get there. All right. Example 1. State the quadrant in which theta lies. State the quadrant in which theta lies. So the next 2 days, we are like satisfying conditions. So we have to meet a couple of conditions today. And so it's important for you to be able to look at the information and figure out, first and foremost, where is it? And so that boils down to which quadrant. That being said, I want to remind you that your projects are due on Thursday. You have a test on Friday.
Are we getting any time in class through project or
No. Okay. Yeah, no.
I was just
All right. What does this say? Sine of theta is less than 0. What does that mean to be less than 0? Oh, negative. Okay, very good. So, again, I'm going to go back to, I'm going to use my little quadrant sketch here. Quadrant 1, the signs are positive, positive. In quadrant 2, what are they? Negative, positive. In quadrant 3, negative, negative. And in quadrant 4? Positive. Good. Positive, negative. Okay. And so we want to know, where is the sine ratio negative? Where is the sine ratio negative?
3 and 4.
3 and 4. Here the sign is negative, and here the sign is negative. So that is in quadrants 3 and 4. So you can do it both ways. I usually just write down quadrants 3 and 4 is where sine is negative, but you can also draw it. What does this mean? Greater than 0. We want to know, where is the cosine greater than 0, or where is cosine positive? Where is cosine positive? Right here, cosine is positive in quadrant 1, and cosine is positive in quadrant 4. So quadrant 1 and quadrant 4. So which quadrant satisfies both conditions? Quadrant 4 works. They both work in quadrant 4. And you can see that here. We've got 3 and 4, 1 and 4. They both work in quadrant 4. So however you want to denote that, that is the bulk of what we want to figure out. Which quadrant are we in? Okay. So letter B. Again, I'm going to do a little sign quadrants here. Negative, positive, negative, negative, positive, negative. So they're telling me cosecant of theta is less than 0. What can I use to help me with cosecant? Sine of theta is less than 0. So when they give you the reciprocal function, you can use the big one instead of the reciprocal. So we want to know, if it says cosecant is less than 0, we want to know really where sine is less than 0. Where is sine negative? 3 and 4. So right there, sine is negative. Sine and cosecant, as it turned out. So quadrant 3 and 4 again. All right, what about tangent? Where is tangent less than 0, or where is tangent negative? Yeah. So tangent is negative. Here, why is tangent negative in quadrant 2? Yeah, because if you divide positive divided by negative, you get a negative result. And down here, tangent is also negative. Again, negative divided by positive is negative. So quadrants 2 and 4, which one works for both? 4, again. And they both have a 4, so quadrant 4. That's it. All right, any questions on that?
No.
That's nada. Sample 2. Sample 2. Find the indicated trig value in the specified quadrant. Oh, this is a typo here. Sorry. This should be 3 over 2. Find the indicated trig value in the specified quadrant. Now, if you were to actually look at this out of the book, they do it an entirely different way, which involves Pythagorean identities and a whole lot of stuff. And I think that, hey, let's just draw the picture and then be able to answer all the questions. Concretely, shall we say. So cosecant of some angle is 3 over 2, and that angle is in quadrant 2. That's what that first line says. What we want to remember is that if we have a trig equation, if they've given us a sine, cosine, tangent equation, then we should be able to draw the related triangle. And in this case, I want to draw that angle in quadrant 2. So we're going to start by drawing a picture. Now, this is angle theta. Theta is this angle in standard position. It's got its initial side on the positive x-axis, and it's ending in quadrant 2. So I'm just going to call this giant angle theta. What we need to do is create the reference triangle so I can have my related trig ratio. So how do you create that reference triangle? Yeah, you drop an altitude straight down to the x-axis, and we create what I'm going to make a note of as theta prime. This is a prime marking. It's just a little like apostrophe almost. It's a little tick mark. Theta prime is going to be our reference angle. All right, it's the angle that's between the terminal side and the x-axis. It's always really close to the origin. All right, and because we have this reference angle or reference triangle, now I can see my opposite side and my adjacent side and my hypotenuse. So if I know that the cosecant of this angle is 3/2, where do I put the 3 and 2? Where does the 3 go? Hypotenuse. And where does the 2 go? Opposite. Yeah, so the hypotenuse is 3 and the opposite side is 2. What do we need to do? Find the third side. I'm going to call it x. Now let me ask you a question. Can x be a positive or a negative value? Negative.
Negative.
Can you have
Yes, theoretical.
Negative.
Yes. Yes.
Yes.
Yes, please. Yes, thank you. I put the little strip on there. The magnetic strip. All right. So yes, this is obviously a theoretical triangle, but we are here is the origin. This x value is to the left. So what should it get? A negative. So we want to be careful where we're attaching negatives now, okay? So we have to be a little bit cautious. So leg squared plus leg squared equals hypotenuse squared. I'm going to subtract the 4. So I get x squared equals 5. And then when we take a square root, we have to remember plus or minus. And that's where you need to, hopefully you drew a good picture. Okay. All right. And so what should we give our x here? Negative value, negative radical 5. Okay. So make sure you're very, very careful now because our triangle can be in many different places. The signs are going to change and you have to pay attention to that. All right, now we want to find the cosine of angle theta, or cosecant according to our reference angle here. Cosine is adjacent over hypotenuse, and that's going to be negative radical 5 over the hypotenuse of 3. Okay? All right. So once again, they're giving me a trig equation here. And anytime we have a trig equation, that means we have a triangle to draw. This time the angle is in quadrant 3. So I'm going to draw my angle theta in quadrant 3. So that's a big angle. There it is. There's my big angle theta ending in quadrant 3. What do I need to do in order to set up this ratio? Drop your altitude to the x-axis. It always goes to the x-axis. And then I get my little reference triangle, which is always between the terminal side and the positive x-axis. Or not positive, and the x-axis. Now that I have my triangle here with my little reference angle where I'm looking from, I can label my sides. Tangent is opposite over adjacent. So the opposite side is right here. Should I give it a 3?
Yeah.
Ah, very good. It should be negative. Why is it negative? It's going down. The adjacent side is 5, but is it 5?
It's negative 5.
Oh, it's negative 5. So what? Why did they give us 3 over 5 instead of negative 3 over negative 5? Yes, because it simplifies. And that's where this can get hard. You have to figure out, where do you put the negatives? If you draw a good picture, then it's pretty easy to see we should have negatives. Okay? All right. So again, I want to find the hypotenuse here. I'm going to call it R. Make sure you do this carefully. So leg squared plus leg squared equals radius squared. That's going to be 9 plus 25, which is 34, equals the radius squared. Now, again, we would take a square root and we get plus or minus, but here's the one thing. This is a hypotenuse. It's a radius of a circle. It cannot be negative. It always is going to be positive. All right? So the hypotenuse, yes, is always positive. Yes. Always positive for the hypotenuse. It's the legs of the triangle, the x and the y, that can change signs. Okay? Now that we know that, we can figure out what is the cosecant ratio. Cosecant according to theta. Looking from our little reference angle here, what's the cosecant ratio? Hypotenuse over opposite, so radical 34 over negative 3, or negative radical 34 over 3 would also, same thing. One more. Questions on these two? Yeah, right? It's the Pythagorean theorem. Yeah. Drawing pictures. Yeah. Really good. Good stuff here.
Good stuff.
Okay. So I told you, like, the Pythagorean theorem is like 90% of Trig. All right, here we go. Last one.
Yeah.
Last one. Secant of some angle theta is -2. And sine of that same angle theta is less than 0. Couple of conditions to meet. They didn't tell us right off the bat. We're in quadrant 2. We're in quadrant 3. So we have to figure out where to draw it. So I don't know where to draw this angle yet. Okay. So first, here is my trig information. I should be able to draw a triangle. But it's actually telling me something else too. I know that the secant of my angle has a negative value, which means that the cosine is also a negative value. Okay, so which quadrant is cosine less than 0? So cosine is less than 0 here in quadrants 2 and 3. So this is possibly quadrants 2 or 3 right there. And we also know that sine of our angle is less than 0. Where is the sine of our angle less than 0? So right here, sine is less than 0, and here sine is less than 0. So that's quadrants 3 and 4. So where should I draw my angle? Quadrant 3. So theta is in quadrant 3. So I'm going to draw my angle here, landing in quadrant 3. Right there is big theta. All right. And again, I'm going to drop an altitude and create my reference triangle between the x-axis and that terminal side. It's slanted.
I was like,
That's not better. Pretend it's straight. Okay.
that one's
All right. What do I do with this secant of theta is -2?
it's
Hypotenuse over adjacent. I only see hypotenuse here. 1. Very good. So turn it into a fraction. Hypotenuse over adjacent. Now, my hypotenuse, can it be -2? No. So the adjacent side is going to be -1. Oh, it's tricky. The hypotenuse cannot be -2, right? Okay. which means the negative has to go with the other number. Okay. All right, what do we need to do next?
Find the opposite.
Find the opposite side there, the y side. All right. So negative 1 squared plus y squared equals the hypotenuse squared. I'm going to subtract 1, so I get y squared equals 3. And when I take a square root, plus or minus radical 3, what should we use? Yeah, we need the negative radical 3 because our leg is going downward in quadrant 3 there. All right, now we have to find all 6 trig functions of angle theta: sine, cosine, and tangent. Cosecant, secant, and cotangent. What do we already know?
Secant.
Secant is negative 2, and it's always a good idea to double check according to your picture. Secant is hypotenuse over adjacent. 2 over negative 1 gives me negative 2. So we set our triangle upright. It's a good idea to do that. If you know secant, what's cosine? Negative 1/2. Very good. Flip the fraction. Okay. Sine, according to our reference angle, is opposite over hypotenuse. Good. Negative radical 3 over 2. Good. Tangent, according to our reference angle, is negative radical 3 over negative 1, which would be radical 3. Positive radical 3. Good. We can flip these for the reciprocal functions. That becomes negative 2 over radical 3, but what do we need to do? Rationalize, which would be what? Good. Negative 2 radical 3 over 3. Good. Cotangent. That's, I can flip it over pretty easily. 1 over radical 3, but we rationalize to get radical 3 over 3. Very good. Do you have any questions for me?
Nope.
Okay. All right, I'm at it.